this is John. Welcome to part 3 of my KiCad tutorial. Last time we ended by exporting a netlist like this. We can always do that again over the top of an old one if we made changes, so I'm going to go ahead and do that anyway. Generate netlist, and it's going to put it in the same project, in the same folder and everything, once you've got your whole thing done. Okay, so you can now, well, we'll leave this open for reference. I'll shrink it down. Leave the window on my desktop here. Okay, so let's open up now. When you're done with the schematic, you open up the PC board editor. Okay, and so that starts out like this. You can sort of see it has a page just like the schematic layout, but the notion of a page is kind of weird in my opinion when it comes to the PC board, so I just ignore it. And I dive right in. Okay, so when you're on the PC board, the first thing you want to do is say, hey, read the netlist that I created from my schematic. And all the defaults are reasonable, especially for the first time you import. And you hit read the netlist. You can see a bunch of parts showed up there. We'll get there in a second. See all this green stuff down here? Scroll up through this. If there's anything red at all, you have a problem. The only thing that usually happens that's red is like, oh, there's no footprint for J5 or something like that. And that means that you just simply forgot to give it a footprint in the schematic editor. But we did all that, so we can hit close. And I'm dragging this around right now. Okay, so I'm going to hit my left mouse button and put it right there. So this is just a clump of all the parts that are from our schematic. We certainly recognize them to some degree. This guy over here is the jack. Hit M. Just like in the schematic editor, I can grab it and move it around. The notion of hovering and selecting is a little different in the PC board. In the PC board, you really want to select it before you hit M. You don't just hover. This guy up here is still selected, so if I'm hovering over this and I hit M, I'm really moving the other guy. So a little bit different, but make sure that you don't get a little confused about that. So you can see the parts in here. These are the part values, like the 10 microfarad, 22 microfarad, the LED, and so on. We'll move that away. Click on. Now I can see I clicked on the part reference. If I hit M now, I'm just moving this J3 around. I'm going to hit escape because I accidentally did something I didn't want to do. Just try clicking somewhere else. Sometimes, if you want to move a part, you can also click on a single one of the pins, and that'll move the whole part, okay? Because you're not allowed to move the pins around. But the problem was when I clicked here, like I just did right now, I'm moving this J3 around. And I don't really want to do that. I'll hit Control-Z to leave it, to undo and put it back where it was, all right? This J3 inside here is actually different than the J3 over here. We'll talk about that in a minute. Let's just separate these parts around. So I'm going to grab this pin on C2 and just get these things apart from each other. Hit M and move them around. M and move it around there. Hit M on this guy and move them up here so that I can see what the heck these all are. Now, the reason I left the schematic around is because the schematic is not perfectly optimal just yet. You'll notice that, you know, you certainly got U2 and C1 and so on, but I'm like, oh, I can't remember where C1 was what I had in my mind. In this particular case, there's a lot of help. These air wires, if I hit M and move this around, you see how it's grabbing on to this pin right here, pin 1 of C1 and pin 3 over here on this guy. It really wants to be associated with that pin. It's also associated with the pin 1 of C3 over here. So I'm going to move that around. Okay. Both of these capacitors actually do the exact same thing. If we look at the schematic, they're really in parallel with each other. They go between the power supply and ground. Power supply and ground. So if it really wouldn't matter if you put C3 up here and C1 down here because they're the same, but it would be a little disorienting to somebody looking at the board in the schematic. You want to use C1 next to U1 just to keep things consistent. So I want to put C1 near U1. Okay, that's the guy up there. Move, put him up here. And C3, move, should be near U2 like that, all right? And the output pins won't be so much of a problem because they're unique. So C2 must go up there. C4 goes down here somewhere. And when I just do, literally, this is how I lay out my board. I kind of shuffle the pins around until I kind of see, all right, what am I supposed to be doing here? How do I want it to kind of come together? How big do I suppose it's going to be? Here's the resistor for the LED. Those are going to go together like this. Okay, so what are the knowns, right? Remember at the beginning, what we want to do is design a power supply that outputs the 5 volts and the 3 volts on these two connectors. Can't remember which is which. Let's go down here. Look at the schematic. J1 is going to be the 3.3. So this is 3.3. Of course it is, because there's the 3.3 regulator. I can select, like I did there, left mouse button, all these parts. Hit M. I can move the whole bunch as a lot. No problem. Grab just the regulator like this, and hit M, I can move it down here, and so on. All right, so back to the knowns, right? Okay, let's talk a little bit about the grid and the fact that these two connectors, these pins, that inside is pins, need to be exactly 42 millimeters apart, because you remember in the earlier video that these are supposed to go into a proto board, and I happen to, with the calipers, I measured that the center of this pin to the one that goes on the other side exactly 42 millimeters. So let's start by getting these placed where we want to put them to ultimately be, and we'll work around that, because it's the only thing that's certain, right? First thing I'm going to do is right-click in the general background. See this down here? Grid. Now, what do we want to do? Those parts need to be 42 millimeters apart exactly. Now, to get them to sit where we want them, we need to pick a grid spacing that allows us to put them in a multiple of 42. So if we set our grid to 1 millimeter, what that means now is if I grab a part and I move it around, see how it like jumps? Ding, 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 ding. Those are jumping around in exactly, that's not 1 millimeter, it's probably 0.1 millimeters. Let's take another look at the grid. 1.0 millimeters. You know, that is exactly what that is. So this thing will move around on its center. The center of this pin right here, I want to make it exactly 42 millimeters from the guy on the other side. Now I can also see this is rotated, it's crooked. Remember, these two things have to line up so that your proto board can sit here and run. I'll make it run vertically up this way. And remember, the traces go like this and like that. So this is sideways. So if I grab the part, I'll just keep clicking until I can see I grab the whole thing. And I can hit R. Okay? I need to make sure that the two grounds run in the line with the pins on the proto board. Okay? Same thing on the other guy. Select the whole thing, hit rotate until you have the grounds lined up. Now, my proto board, it has a red line and a blue line, and then all the other pins, and another red one and a blue one like this. So I want the grounds to sit in the blue lines, all right? So these are oriented correctly. Now, this guy down here, add a dimension. Anytime I want, I can just draw a dimension and use it as a reference. Now, before I do that, I just hit escape. As I started doing something I didn't want to do, hit escape to stop that. You have all these different choices over here. PC boards are made up of layers. There's copper on the front, there's copper on the back. There's silk screens on the front and back. The silk screen is what all the white writing is usually on the PC board, so you can see where J1 is, and you put your name on there and stuff like that. You draw on each one of these layers to tell the manufacturer, you know, do I want to, if I put text on this layer, they're going to draw that text with copper. And that's kind of fun to do sometimes too. But I don't want them to put this dimension drawing in the middle of my copper or on the silk screen. That's just for my own reference. So this drawings user or comments and stuff like that, these extra layers in here are specifically intended for my own notes and annotations. So I'm going to select drawings user, this little arrow right there. And then I'm going to come down here to this draw me a dimension thing. In my grid, as you already saw, is set to go to 1 millimeter exactly. And all these little dots in here are 1 millimeter apart, and that's where the center of this thing will always snap to as I move it around. All right, so I want to see a 42 millimeter dimension, and then I'll work around that. So I'm going to click here, and I'm going to move it over this way until I get to 42. 42. All right, boing. I left click to do that one. Now I'm going to slide it up and down and say I want to be able to, set this back so I can use it. I move it up like this and I hit left click again. That third click, I'm done making that dimension. And from this point here to that point there is 42 millimeters. I'm going to hit escape. I'm done drawing the dimension line. If this thing wants to draw it in inches, or you do, here's the same sort of thing you had on the schematic editor over here. You can change the dimension units if you want, okay? Now, remember that 42 millimeters is supposed to be from this, exactly that hole right here. Now, as you can see, there we go. I've grabbed it. Sometimes when you grab a part and you move it around, you're not moving it based on what on what you want to hold on to. Let's say I'm going to rotate it around this way. If you see what's going on here, and I'm in the snap to grid mode, I can't get it to go where I want it to go. All right. When that happens, if this is really the orientation I wanted this part to be in, I'd have to change my grid snap to grid dimension to a higher resolution to give me more options until I can get that right in the middle of that pin. All right. I've used a number of different CAD packages, and some of them let you do things a little bit differently. So what I'm doing here is if I grab the part by clicking here and I select the whole thing and I hit M, you'll notice it wants to align my movement in the reference to where I'm placing it on pin number 1. That's actually a feature of KiCad. All right. But I really want to, let's say, I know I flipped this is actually upside down. This is only for the sake of discussion. Let's say I wanted to align it based on pin 3. Sometimes some systems let me move it around centered on 3. Now, this one does. I never noticed that before, so I'm learning something myself while messing with this. If I click this one single pin and I hit M, I'm moving it based on pin 3 being snapping to the grid. All right, so that would be one way to get that thing lined up right on there, if this is what I really wanted. If you grab the whole part, it doesn't know what to use as the middle. I guess it's using pin 1 in that case. It turns out it's probably actually using the origin of the part as defined when you created this footprint to begin with. When we do a video on footprints, we'll play around with that and we'll see what's going on. All right, now, that was just for sake of discussion. This is flipped upside down right now. Remember, as I said before, I really want this thing to be ground and power. Ground on the right, power on the left. The same thing with the other one. I want ground on the right, power on the left. I'm going to move this one. So this one, I actually do have the problem I was demonstrating on the other one. This one is right. The power pin is the one on the inside. This guy is the ground pin is on the end one. So now I'm going to grab the ground pin, one of the ground pins, and move it around based on that being in the middle. Why can't I do this? Hello. I just did it. Move. There we go. Now you can see I'm snapping based on pin number 3. Okay. Now we have to be careful because we might actually have the vertical motion messed up. It does not appear that that's the case. And it's of course not the case because when I was moving it based on pin 1, it's on the bottom. Okay, and it's the left one. Now I'm on the bottom and I was moving it based on the right one. This is the way to get these things lined up on 42 millimeters. Now I say that because remember the centers of these pins is 2.54. If I chose this one, what would happen is I could move it left and right and get it lined up, but now I can't move it up and down per se. Let me try that again. Move. Because remember it's going to be centered in both the vertical and the horizontal, and now I can't get it to line up with the guy on the right. It's too high or too low. That's a problem. And it was because I grabbed the wrong pin. It's as simple as that. If I grab this pin down here, clearly I can line it up vertically with the guy over here. Plus, I can line it up horizontally to make it match this dimension line. So these two now are exactly where I want them to be. Now, I don't want to accidentally move them. I went through a lot of hassle to do this, to get them there. I'm going to highlight this, and I'm going to hit E to edit this component, this footprint. And I'm going to find in here, so where it says lock pads, this means move the part, but don't let me relocate the pads. I've never tried this. If you hit free, then you can actually relocate the pins and stuff like that. That would not be a good idea. If I hit lock footprint, now what happens is, I'll give you a little thingy. component is locked. It cannot be freely moved or auto-placed. You can't touch it. You can't do anything. Okay. I don't want to accidentally grab this. Now I hit M, and it's going to say, oh, you don't want to, it's been locked. Now it will let me override the lock. Of course, I could unlock it, or I could say yes here and move it anyway. But at least it lets me know what's going on. So I'm going to now left click to select this and hit E, lock the entire footprint. Okay. Now these are locked. This is really where I want them to go. This will fit in my board. They're aligned vertically and they're 42 apart. Awesomeness. Now it's just a matter of you figure out where these other things got to go. Oops. To fit this in, a reasonable sized PC board. So what am I going to do? This is a power filter. I could probably put the filter capacitors like right up next to these things. I'll give myself a little bit of elbow room for soldering. There we go. Now we're in a situation where it's like, that's not so good. This isn't so good. They're both kind of a little bit off, a little bit annoying. That's because we have a whole 1 millimeter on our spacing right now. If we go down to say 2.5, it gives me 4 times the resolution. Now I can make it look really nice and get it centered, if I really want to make it look pretty decent there. Okay, so this is probably, I could put this regulator like that maybe. And now I want this guy to go in there, and just like the schematic, you can rotate these things around. This is going to connect those 2 outside pins in my regulator. All right, so that's roughly maybe a good place to put that one. Hit M. Select it and hit M. Now we're kind of symmetric, so I could probably flip it over and go the other way and kind of do the same thing. And flip it over. Oops, there we go. Move this guy. Now this is the same thing as the other one. We'd probably want to make it look symmetric, like, we meant to do that. Let we have some idea what we're doing. Move it around and see if we can get kind of match this distance here. So, it looks like somebody cared about what they were doing when they did it. All right, C3. That goes between these 2 pins, just like that other guy. Hit rotate. Now you can see it's backwards. Rotate it twice more, and now it fits nice. All right. Now it turns out I've used these regulators many times before. It turns out you can actually put the part pretty darn close. The reason these white lines are around these parts like this is because that tells you that you do not want the part any closer to some other one. You don't want these white boxes. This is the outline, what they call a courtyard. You don't want this thing so close to the other one that it might knock into it. All right? So they give you these as a bit of a reference and say, you want to avoid getting any closer than that. So I'm going to go ahead and put it up really close because I happen to know that when you put this regulator on here, the pins sit like right in this area right here. And you have plenty of room, in other words, to get your soldering iron in there. It's really not a problem. These white lines that you see connecting things are called air wires. And I should have brought this up first, I guess. They're there to give you a reference to let you know ultimately where these things have to be connected. So there has to be a copper trace going from here up to there, and another one from here up to over there. The fact that they cross is a little annoying, but we'll see about that in a minute because I happen to know that I'm going to have room to route the copper where I want it to go, even in this kind of a configuration. We can also turn these or flip around or put them on the other side of the board or whatever we really want to make things viable. I'm going to move this now. Now hopefully this will fit in here. That looks pretty good. I'm going to put it here, and you'll notice I'm making kind of a U shape here. And the reason I'm doing that is because when we're all done with this, what I'm thinking about doing is when I make the PC board, I'm going to hollow it out in here. Because those breadboards, if I put this on the ends, I want to be able to access all the pins in the breadboard. So it's going to actually be a board that'll be shaped like this, and this will be hollowed out and around like that. Okay? So maybe we'll have something that looks a little bit like this. Now, it doesn't really matter to me whether how I put my LED in there. If I put it in like this, we can see the ground pin goes here and this one runs around to there. It might be easier to rotate this thing around like this, maybe even put it in like this, because then the traces don't ever cross or they won't have to run around each other. That would be nice. Go ahead and maybe make this go like this or something like that. We have plenty of room on this board. There's not a lot of parts on it. And we can make it as big as we want, do whatever we want. All right, so now we pretty much have this thing laid out. If we can just connect the copper together, I think we have a pretty viable thing here. I'm going to Control S to save this. All right, now before we do any copper or anything else, if you hit Alt 3, is what I was mentioning earlier. When you pick the footprints, they have pictures of the parts, 3D parts, so you can look at you can actually see what it might look like when you're done. Now, this board is weird shaped. I didn't tell it what shape to make the board, so what this did, when I said show me what it will look like in 3D, it just drew a board that encompasses every single thing in my drawing, including the dimension, which remember is sitting up here. So it doesn't know yet. I didn't tell it what shape or size to make this board. Now, this 3D image of this LED, remember when we picked the LED, it said clear or flat top and so on, and I just picked generic. And you have a generic 3mm LED there. So you could put it together and it would look like this. Now, whoever made the part for this connector here did not give us a 3D rendering model of that part, and that's fine. It's a lot of work sometimes to make those. You can download them, but 9 times out of 10 I don't make them either. I know what this looks like, and I know it fits within this white box. The white drawings on here, these are the silkscreen drawings I mentioned about on that silkscreen layer. This is J3 over here is not on the PC board, and it would be annoying if you made it this way. You're free to do so. You just won't have a labeled connector over here. So one of the things we need to do is make sure that we move around our silkscreen legend, these parts indicators, so that we can see them, that they all look nice. All right, so this, roughly speaking, is our board. So one thing that's weird, other than the board being too big, these connectors are facing the wrong way. Now, you know and I know that these things are just as easily, you can flip it over, I could just flip it over and solder it sticking down instead of up, and this would be okay, but it's not very high quality to do this. So what we want to do is flip them over to the other side of the PC board. So if you select this, now remember it's locked, all right? If you select it, by default, all this stuff is on the front side copper, all right? Right now, I'll select that. It doesn't really matter which one I'm playing with right now. It will when we start drawing traces. I want to draw on the front or the back. I have to tell it. If I select this and I hit F, that means flip it to the other side of the board. Now it's going to warn me and say, look, you told me to lock this, and now you're moving it. Is that okay? Yes, it's okay. I want to flip it over. Now, when I flipped it, what did it do? It looks like it flipped it in the vertical axis because the ground was on the right and the power was on the left before, just like this one is. But now it's too low. So now I got to grab it again and move it again. Move. It's still locked. Do I want to override? Yes. Now remember, I'm in my grid settings are still higher resolution, so I don't really want to move it. All right, I'll hit escape to abort that. Right click, grid. Let's go back to my 1 millimeters. Now I could eyeball it and I could get it on there right, but I've made enough mistakes designing PC boards over the years. I know better. So yes, override. I'm moving it by grabbing pin 1. So I know I can get the thing perfectly locked on there because it's going to snap it right to that grid. That's where I want to put that. All right. Now I want to do the same thing with the guy on the other side. F to flip it over. Yes, I'm overriding. Now I select it again. Now remember, if I go to move it, I'm grabbing the pin over here, right? I'll show you that, right? Just like before. Oh, override. Okay, great. But I'm grabbing it on pin 1 and I can't. Wow, it does want to line it up. That shouldn't be possible. Oh, I know why. It's because it remembers that it remembered that before I just hit escape to abort that. It remembered that before I moved it, it was aligned vertically here. So it does give you, in addition to the snap to grid, it does give you one extra point, which is to keep it aligned in this axis. It probably does it in the other one as well. But even so, what I'm going to do is I'm going to grab the pin that I want to move it on. Now it's forcing me to grab the whole one, all right? I suspect that it's doing that because it's on the bottom of the PC board and I'm currently editing the front, right? Let's go to the back. Now let's try to grab it. Oh, come on. Why can't I grab a ground pin? Footprint or the value? What's going on here? Let's just move the whole thing. Maybe it's because it's still locked. Let me edit this and unlock it. Okay, it was because it was locked. So now I can move it, and I'm grabbing that ground pin. Now I'm doing the right thing. We can see that I'm vertically aligned here. I'm going to just do that by looking. See that white line that runs across the screen here? That's a pretty nice reference. I am going to make sure that it's in the right spot relative to that line up there, which is this one gap like so. He's got that gap, and the right pin is on the dimension line, and this left pin is on the dimension line. And it still says 42. I didn't accidentally move that or change it. So now I'm going to Control S to save, Alt 3. Now it's sticking it out the back. And the legend, the silkscreen lines, are on the back where they belong. So if somebody puts this together who doesn't really know a priori what it's supposed to look like, at least it's labeled correctly and they're told to put it on the back. All right, so now we've got that all taken care of. All right, so I hit Control Q, or I click the upper right hand thingy to close the 3D viewer. All right, what are we going to do here now? All right, these are placed. Oh, let's relock them. E to edit, lock it. Okay, I think this one's still locked. Edit, yeah, okay. All right, because again, we don't want to accidentally move it around. So now we're looking pretty darn close. This guy right here that says edge cuts, that is the layer that you want to draw your board outline on. That says, here's where I want the manufacturer to make the board. I want it this big, and I want the parts to be placed on the board relative to that. So if you get edge cuts and you grab this guy right here, graphic lines, what I'm going to do is I'm going to just draw a line on this layer. Now, I'm still in 1 millimeter grid mode. And if I draw a board outline, the corner of this is somewhat asymmetric. I'm going to hit escape. I don't like that. If we go back down to the grid and give ourselves more resolution, remember we were at 0.25 earlier, and that seemed pretty reasonable. Now if we look at the corner of this, if we draw the edge of the PC board to this point right here, it's pretty close. It's not quite perfect, but it's pretty darn close. I think that's okay. And we look at the corner of this one over here. This one is basically the same way. So at least it'll be symmetric, and it'll look like we meant to do that, and we're not just some slobs, right? So we're on edge cuts. We are going to draw a bunch of lines from right here. Left mouse click. You see we're drawing this yellow line. Yellow is the color for this layer. Each layer has their own color. And you can see it's a little bit crooked. I have a pretty high resolution, so I have a lot of options, right? So I'm going to zoom way in and make sure I pick exactly where I want it to go. I'm going to left click there, and now I'm still drawing. Okay, I'm going to come down here somewhere, and I'm going to say I want the board here. Now, you can let the connector stick off the edge of the board, or you can make the board go around it. I'm going to go ahead and do that. I'm going to let everything will be fully within the board outline. And I don't really know where this point is. So I'm going to purposely just put it like right over here and show you how to fix this. Because this happens to me a lot. You don't really know exactly where it's supposed to be. You know where it's going to end. It's going to end right there. And I'm still hitting the left mouse button. And now I can't it won't go away. If I hit escape right now, what will happen is the very last segment will disappear, and I'm left with the guys that I drew with the 4 clicks. Now, the problem is, this point I didn't really know where to put it, but now I do. I want it to line up with the with this dot up here. There's a couple ways to do that. I can zoom way in, put the cursor there, and then I can look down. This down here gives you the X and Y coordinates of all these, and the X coordinate says 115.5. And as you can see, if I move it back and forth. So I know that that in the X dimension is 115.5. The other way to do it, which I do quite often, I'll hit escape, If I click this line, you see that lights up over there? I can just, move it around until you see all the little stair step jaggies. I know it's aligned right there. I can also look down and see the 115.5, and I can move it to the bottom and where it's going to be. That one really wants to end there. Now I just released the left mouse click. I left mouse click over here to unselect it. Left mouse click there. I got a little handle on there now. I can move that in and make it where I want it to go. One click over there, or hit escape to stop selecting. I'm going to hit Control S to save it right now, because it would be a good idea to do a checkpoint save. Now let's do an Alt 3. And now it's starting to look like our board. You know, all we need now is to just draw, hey, put the copper here and we can use it. Now I would like to cut this out. I'm going to show you how to do that in another video. In this one, we're just going to wire it up now and let her go. I think this is okay for the connector. This is probably all right for where the regulators are. They don't quite line up with each other. It would look cooler if they really did, or maybe I could actually put the regulator over here, grab it, rotate it. I could actually put the whole regulator right over here if I really wanted to. Pin 2 is the output of the regulator. And this air wire that runs over like that is because the ground is connected. I'm going to have ground everywhere. So I'm not that concerned that this wire is screwy. But pin 2 goes to here, it goes to there, goes to there. That's a nice path to route the copper. I could put the regulator over here, and I could put this little capacitor over there if I really wanted to. But let's think about this for a minute. On the PC board, I'm going to want to draw in the silk screen, hey, this is going to be my 5 volts or whatever. It looks like this is the 3.3 regulator. I can see it in there. This thingy right here, the 3.3 TRG1. So this I would put, in the silk screen really big and write 3.3 volts. But I can't do that if I put this regulator here. So maybe I was better off before. I'll hit Control Z and put it back where it was. And now I have some room to draw here. Maybe that's a good idea. Maybe it's okay. Why not? It doesn't have to be perfect. We just want to make it look like we meant to do something useful here. So that's probably okay. I'll hit Control S to save it again because I was playing with it. All right, now let's draw some copper traces. If you click, first you got to pick the layer you want to draw on. I'm still drawing the outside border of this thing. I'll draw on the front. Grab this guy. Now there's a lot of settings, and it would be easier to do this if we went through and configured this before we started drawing. That's not as much fun. And 9 times out of 10, you have to tweak things anyway. If I click on here and start drawing this trace, you can see I'm drawing copper in red. That's the color for the front of the board. Now I want it to go around like this and then connect there and then go over to here and so on. If I left click right now, it will draw the trace exactly the way I want it. However, that's a really little skinny trace. I want a bigger one. So I'm going to hit Q, and I can change the track width. This is a power line. I don't want a tiny little thing. I'm going to make a whole whopping 1 millimeter thick. Big old fat thing. As you can see, that's much bigger. Now, what I want to do, remember I clicked in here, and this is the first point on my track that I want to route. And even while routing, you just saw me hit the middle mouse button, and I'm sliding this around, which I can do. It's very convenient. You can see it light up all the pins that I ultimately need to connect together. And those were originally shown to me with air wires. So I would expect all this, right? So I connected these two together. Now I'm going to go from here to this guy. And I'm going to hit left click on that guy, and then I'm going to go on to here. Now, that's okay to do this, but the problem with that is if you do it like this and there's that wedge just right up on top there, that's called an acid trap. That's bad practice. This looks like it would be all right if we zoom way in. That's okay, but I just don't like the way that looks. I don't like the cut of that guy's jib. What I want to do is make it kind of come around here. So I'm going to click it and say, yeah, you can draw it, but don't help me. I want it to go this way, all right? Now I left click there, left click again, left click there. All right, that whole track for the 3 volt output onto these pins here is all done. It's okay for it to kind of do this, but let's say I don't like that. I can click here and I can hit then delete. Now I happen to know that there's a little bit of the track right here. If I click there, I can now, I just selected it and I can see it and I can say, okay, get rid of that one. So maybe what I meant to do is to have it come out this way. And then I want it to go a little bit to the left from here. And then I want it to go to that pin. So now it's like, ooh, super fancy, right? If you want to do that, you can, is my point. So now I'm going to grab here. And because I'm still drawing, and I remember it was still set to draw fat tracks, it's going to continue to do so. I connect these grounds together. But I don't really need to do more, and I'll show you why in a minute, because what I'm going to do is I'm going to fill the whole board with copper and say just make everything ground that has otherwise not been assigned. Let's see here. Now I can see this pin needs to go to here, which needs to come up and around to there, so let's go ahead and do that one. So this guy comes up here, and then I want it to go around this corner. Now, again, I need to be careful about our acid trap problem, so I'm going to go to here, and I'm going to click there, and then I'm going to go from there straight up and make it a hard 90-degree turn. Now I need to go from here around over there. I can do that by coming like so. You could just do this and take its recommended path. That's okay. It's going to keep you away from this ground pin. It won't let you short it. It won't let you go and connect it to where it's not supposed to go. And a lot of times I'll do that. But I want to keep it further from the ground pin, that far as I can. Okay, maybe I'll go up and around this way. I could do that. Sure. And I'll show you another thing now. I'll hit escape. So remember, the pointer moved from the track to there when I hit escape. If I click this and I hit, I think it's G, I can mess around with it after I've routed it, and clearly I could even put it where it doesn't want to go. If you really want, if you really want to do something fancy, right? Like maybe I want to do this or whatever. Yeah, sure, whatever. Leave it there. So you have quite a lot of options on how to draw copper lines and things on here. So let's do the other regulator now. Boom, boom, boom. Well, maybe I'll go to here first, and then I can go like that. That's fine. This can be, depending on what you're doing, a lot of circuits really are pretty reasonable, and you can be pretty sloppy with it. It's really, when you're dealing with big fat traces for power, it's DC, there's no AC component really to these signals, it's okay. Just get them connected and they'll be fine. It's just the power. For some reason I want to line these up, so I'm going to go ahead and move this guy over. And I can see it can't really go because my grid settings right now are not high enough resolution. That's close enough, I don't care. It looks a little bit decent, so I'm going to go ahead and connect that to there. What I'm going to do, I'm going to run this guy over to this pin. That's good. Run him over to here. That's good. All right. Now, it's basically entirely route. Oh, yeah. Okay, these ground pins. Let me leave these unconnected and these connected, and I'll show you why and what the difference really is. Control S to save. All right. Now, this guy over, these turn it on. This guy over here, I'll show you the ones on the left in a minute. Just like drawing a trace, I can go over here and I can say add a filled zone. Remember, I'm still selecting the front copper. Filled zone. If I draw a box around the entire thing, okay, I just clicked up in the left, this thing pops up. It says, you're about to draw a giant, polygonal shaped shape that I'm going to make into copper on the front layer, and I'm going to connect. What do you want me to do? I could either just put copper on there that's not connected to anything, or I can say connect it to ground. Okay? And there's some settings in here, and I'll play with these settings in a minute so you can see what they all do. But I clicked up in the upper left over there. It doesn't have to be perfect. I'm going to actually draw this around the outside of the board. So I hit left click over here, and then to finish it, you click and you close it off just like we did the other guy. Now, for some reason, this one lets you finish it while the other guy keeps drawing. That's fine. Hit escape. We're done. So what this thing is, now you'll notice this whole thing turned red in here. Why? Because it's all one big copper thing. And because I drew the edge cut, the board outline, I don't know why they call it edge cuts. Every manufacturer I ever dealt with calls it a board outline. It knows you're not supposed to put copper outside of the board outline is my point. And it says fill this region to the best you can with copper. Let's zoom in what happened over here. Now it knows, because I told it, that this big region is supposed to be connected to ground. So everything that's labeled ground, you can see a little spoke in here connecting it to the ground. And otherwise it just fills everything. All right? Every one of the pins that says ground, it's connected with a spoke. Now, remember, I put a track here. I made it 1 millimeter wide. These spokes are narrower than the 1 millimeters. Okay? Now, maybe you want the spokes bigger. Maybe this is fine. Yeah, I'm sure it's fine. These round ones, you see kind of a wagon wheel. You still have the spokes. This is not connected to anything, so you don't see it there, and it avoids all these other pins. And as you look around, this is, as I alluded to earlier, how I'm going to connect the ground together on all the ground pins. Now, the problem is, see this air wire right there? This whole region up here is not connected to the ground region below. And the reason for that is it can't get around here. It can't get around here. And there's traces running back and forth to block it from doing so everywhere else. To solve that problem, I'm going to go to the back, and I'm going to click on this again, add a filled zone. Some of the KiCad packages call this a poured region, like you're pouring copper. And I'll just do the same thing. Put it on the ground, draw a box around where I want it to be filled. Whoa, I didn't click over there. I missed it. There you go. Draw it over here, and then close it off. Actually, I wonder if I hit the right mouse click, if it says close the zone outline. That's an option, so you don't actually have to go find it. That's nice. Escape. Now we have a front and a back. The back, since there's no horizontal lines anywhere, the ground does connect up and around to these pins. So if we then go back to the front and we look at the back, you know, there's no more air wire. Why? Because this ground-filled region here is connected to ground through this pin. This pin connects the back everywhere and the front down here. Okay? The front up here is connected to the ground through these pins. Because remember, these outside pins on the back region are connected into the filled ground pour back here. All right, so this is basically, you could export this and you could make it, and it will work. But I'm not super happy about the size of the gap between here. I want this thing really filled nicely, and we want to put some vias in here to make sure that these grounds are really well connected. I want to make these spokes a little bit bigger. So how do we do that? So let's select the front ground pour by clicking on it, and we can now hit E, like we did these other guys. Look at the clearance, the minimum width, anti-pad clearance, spoke width. What does all this stuff mean? Well, the spokes are the things I was talking about. My traces were 1 millimeter. These are 0.508 millimeters. That's why over here you can see they're half as big as this. So let's say you want big fat spokes instead of skinny ones. Well, you can go in here and make it 1. Done. Now they're big fat ones. You can see it automatically redrew them all. That's pretty nifty. Now we might want to do that on the back as well, because we just edited only 1. So let's go ahead and hit E. Now that I've selected the back one, make all the spokes 1. Ta-da! Now he's got big fat ones. All right, that looks good too. Let's click over here and look at the back. Back is less busy. Let's look up here. This again is perfectly fine. We're from the edge of the PC board, based on some distance. We'll in the next video, what we'll do is we'll talk about the manufacturer's rules. We've been ignoring them so far. Other than when I mentioned that, you know, when you put this connector down, some manufacturers can't make slotted holes. They only want to drill them. It's cheaper to make drill holes than there are slotted holes. So even if they can do it, you might avoid it for cost. What I'm getting at is the other settings in the filled patterns. I just had to edit again. These clearances and the distance from the edge of the board matter. You can't have copper all the way out to the outer edge because it'll stick out and then it'll be shorting out and causing problems. You want to have a distance in there. And it's surprisingly tight, what the manufacturers want. Even a 0.5 millimeter is pretty big. I think that if you use Park, which I've used before, I think it's actually like 1/4 or something like that. So you can set these clearances. Right now they're giant. This is, anyone could manufacture this with these settings. I'm pretty sure. These gaps between these tracks are huge. We can go ahead and leave it like this. This is perfectly fine. This is well done. Grab this guy right here where it says put a via down. All right? Bang. A via is a single hull pad. You drill through it. Let me hit escape. Control S to save. Alt 3. Let's have a look-see at our board now. You can see now that the copper's in here in this view, and you can see the gaps between the copper. I'm using my left mouse button. I can flip this over. I can look underneath, and you can see the little via I put there, a little hole right there. Okay? Now, the reason you put vias on these boards, again, you don't really need to do it. This is 10 tons of overkill, but it looks kind of cool. Maybe. Normally what you want to do is you put vias around the outside of your board to connect the ground planes together. And you do that because this is a pretty simple DC circuit. There's no real reason to do it. It'll work fine either way. But normally I do it because if you have high frequency chatter and signals running around on these boards, they need to go somewhere, or they'll radiate off and cause you problems in advanced designs. So normally you see people putting vias around the outside of these boards so that if any stray currents and voltages currents are flowing through the copper over here, if it can't get to the ground this way, it could bounce to the back side of the board and get to the ground over here. You generally want it, the rule is, you want to keep these two ground planes well connected, and you don't want RF signals, wandering off the boards. And one way to do that is to have a ground line around the outside, and to connect your ground planes together. There's probably as many opinions on that as there is anything in the world. So do whatever you want. I generally put these around the outside edge of my board. So I'm going to put a couple of them up here, right? So I'm going to hit this. Now I'm just taking the default settings for these things, which I don't even know what it is. So I'm going to hit Q. Oh, I guess I want to hit E. What am I doing here? Let me hit escape. Let me select this and hit E. All right, what do we got here? There's a position, there's the diameter, and the drill diameter. One of the things that your manufacturers will tell you, I cannot drill a hole smaller than some size. 0.4 millimeters is a pretty big hole, relatively speaking. I don't know of any manufacturer that would have a problem with that. So the default settings for these vias are fine. We can play around with, there's tons of menus up here and the setup and these layers and rules and all this other stuff. You can set the defaults so that when you're placing these, they're all the right size if you wanted bigger ones or something like that. So I'm going to just place a couple of them around and have my fun here. Maybe eyeball it. I don't know if these are going to be perfect. That one doesn't look like it's equally spaced. So maybe I'll put a bunch of them along there. All right. Control S to save. Alt F3. Admire my work. Now I got a bunch of holes along the edge. That's nice. And a hole, and they come through over there. All right. That's all pretty decent. You'll notice that this guy over here, J3, is still not on the board. That's annoying. But everything else is actually readable. In their default position. I might want to put U1 and U2 in the same place so that it's a little more consistent. If I hit front, what do I want to do? Over here, front silks. Okay. So now I'm drawing on the silk screen layer. U1, I want to click on U2 over there, and it doesn't know what I want. I want the reference for U2. All right. Hit M to move it, and move it up here. Now I'm a little more symmetric, right? The other ones all look fine. J3 over there. Let's look at the back silk. All right. This guy right there. I just clicked it, so I selected the J3. I'm going to hit M. And remember that footprint is locked. So I can't even move the legend for the thing. So I'm going to go ahead and override it and just move the little J3 over to the other side. It'll be symmetric to where this J1 is. Okay, now remember we're looking at the bottom from the top. It's not flipped over. All right, we're looking through the top at the bottom, which is why everything looks backwards right now. I'll hit Control S to save, Alt 3 to look at in 3D. This will let me flip it over, and I can now see, oh, that's nice, J3 and J1. And I can have a look-see. Everything looks pretty darn, diggity darn dong good. Okie dokie. We got our nice vias up there. I'll put some down here. And what I want to also do is just draw on the copper and say, hey, this is my whatever, the 5 volt, I think, and the 3 volt is on this side. So I'll close in here. So I'm on the front silks, and I hit the text guy right there. Okay, I'm going to say right here, I want to say, I don't know what I want to say. I'm going to hit escape to abort that. You won. You won. I select this, and it tells me that's the 3.3 volt regulator. Okay, fine. Hit this guy. Boom. 3.3 volts. And I can set the size and stuff like that. Let's put the default in there. That's pretty nice and fat. It's bigger than the part numbers. If I rotate it, I can put it over here so it can say, hey, here's my 3.3 volts. And that's nice. But you're probably going to forget and not, know, is the ground the one on the bottom or the one on the top? So maybe we'll want to put like a plus and a minus on there. So let's go ahead and do that too and say over here I want to put a minus. And I want to rotate that so it looks right. And I want to line it up with that pin. Okay, and over here lined up with this pin. Again, you might not be able to line it up. You might have to change your grid spacing in the grid menu. And I want to put a plus right there. Escape. Save it. Go into here and look at it this way. So when I'm using it on my breadboard, I'll probably have my breadboard like this sticking off to the side, and I can now clearly see that the plus 3.3 is up there and the minus is down there. I also know, because I built it, that I could look in here and I could clearly see that this thingy is connected to the ground plane, and this one clearly goes to a regulator. So I would know, even if it was unlabeled. But don't be a jerk. Label your stuff so that if someone else uses it, they don't blow up all their parts by hooking it up backwards, which would be a drag. Now, if I want to, I can multiple select and copy, and I'm not going to do that. I'm going to just go over here and put another minus. Rotate it. Line it up with the ground pin. Put it down here. And it would be nice if they kind of were the same on the left and right. Let me scroll this. Here's a technique I use a lot. I'll scroll it so that like the minus sign is right near the top of this window border. And now I can clearly see that this one is not vertically aligned right now. I'm going to hit escape, click it to select it, and hit M. Oops, oh, darn it. Now the whole thing went nuts. So it will scroll around a little bit when you move it. So this is nice. I have this highlighted line, this crosshair is probably where it was originally when I grabbed it. And I can see that, if it's right like that, it's lined up. So I'm going to do that. Now it's lined up, okay? Go to text. I'm going to hit a plus over here. All right. And the plus probably doesn't matter if I rotate it the wrong way because it's symmetric. Right, and that looks like it's lined up really nice. And what else am I going to do? I'm still in text mode. I'm going to click down here. I'm going to say 5 volts. Okie dokie. And I'm going to rotate it, and I want it kind of centered between there and kind of put it like this and make it look nice. Escape. Control S to save. Alt 3, not F3. That's Alt 3. So now it would look like this if we had it made. That's looking pretty reasonable. I can use that. I might as well put my name on there and some other things like, oh, I made this board. I recognize my great soldering technique. But which one was it? When you've made 100 boards, I got to remember, oh, heck, which project was that? Well, remember, this is my project number 2044. So I always put things like that on here. Remember, what the heck was this thing? So let's go ahead and put it over here. 2044-breadboard power. Now, it doesn't need to be gigantic. This will be annoying. I'm going to make it a 0.5 millimeter, super tiny. Now, manufacturers won't be able to do this, super small. Some of them may have to make it bigger. They'll override your settings. 9 times out of 10, or they'll do exactly what you said and it'll be blotchy and it won't work. I'm pretty sure that we can go ahead and do this. If I send it over to Oshpark, I've done some pretty small stuff and they've always succeeded at it. So, and that's another thing you want to do when you send out your first board. Do a cheap one the first time you use a vendor to make sure they know that they can make what you want them to make. Send a test board over there with some extreme distances. How close together can your copper be before they accidentally put shorts in here and stuff like that. You'll want to do a test board. Fortunately, this board here will probably cost $5 or $10, and you'll get 3 of them, including shipping, which I consider a pretty good price. You can get the board for less, like from China or something like that, but then you got to pay $20 in shipping. So if you make a little board like this that's about 2 square inches in size, it'll cost you $10 at Oshpark, and you'll get it in about a week and a half or 2 weeks or something. And that's pretty reasonable in my opinion. Now, I'm a fan of the open source guys, so why don't we go ahead and put the open source logo on here. So right in the middle of here, I can actually put an extra footprint that's not even in the schematic, and I can stick it right there. Now, how does this thing work? I can search, I can list everything. I don't remember how the heck to do this. Select by browser. The problem with the browser is I don't know how to search in the browser. We got zooms and stuff. Close this thing. I can never figure out how to use that. That might be another video someday when I learn how to use it. I happen to know there's an open source hardware option. I list everything, okay? OSHW. And they give you different sizes. So this one is 7.3 millimeters and so on. We don't have a lot of space. And there's a couple of different, if you're going to draw it in the copper or on the silk screen, they give you different versions. Right now I've selected the silk. I want to draw this with the silk. And you got big ones and little ones. Here's the differences have to do with where they draw the text. I'm going to grab the smallest one. That will be this one right here. Open source hardware. I'll rotate it like this because these other text like this is all this way. And when you use it, it'll never be sticking up like this anyway. So I'm going to go ahead and say, oh, well, this is going to be an open source hardware project. Put that nice little logo in there. And this is all looking pretty good. The breadboard power looks nice down there. I'm going to go ahead and do this, and I'm going to move it up like maybe up here. Why? Because I want to leave a little room below it. I'm going to put another thing down here, and I'm going to say copyright me 2019, which is fine. Even if it's open source, you still want to put a copyright on there and a license file and all that other fun stuff. Now this is way too big. I'm going to edit it. Remember, this other guy was a half, right? I said the width and height was 0.5 and 0.5, and this was like 0.1, I think. Okie dokie. Now it looks good. Move in here. All right. Ta-da! Now, if I was going to give this thing away, I would include with it a license file, and I generally give my stuff away using the CERN open source hardware license. The CERN guys, by the way, I think are the ones that maintain or even created KiCad. And the CERN license, hardware is a little different than software. We could talk for days on licensing. Basically, the CERN hardware license is you take it, do what you want with it. It'd be nice if you'd let me know that you used it for something, because I'd like to know, did my work get used or not? And that would be the license file that I would put in this project if I really wanted to do that. I'll just leave it like this right now. I'll put this thing on it to let everyone know, even though I retain copyright. It is open source, and if you want, you can ask me for the files and I'll give them to you. But this video is about how to create your own. You should create your own. Why don't we go ahead and throw couple more vias in here just for fun, and then save it, and we are done. Now if you put vias where your text is, like if I put it right there, some vendors will put the text there and you'll be able to see it, other ones won't. I happen to know if you go to Oshpark, I think what they do is they don't put the silkscreen in over the via holes, so you wouldn't be able to read it. You could do something like this though. If I moved it and put it like right here, that C would print. All right, it might be that the bracket, if you stuck it like in the middle of an O or something, yeah, it would be fine. If you want to be silly about it or something like that. Anyway, these are not super required anyhow, so not a big deal. I'll just put a couple more over here, maybe one there and one here, and we'll call it a day. All right, save. Now, if you go to OshPark, you're done. You save this file, and you can send them the KiCad file, this PCB file, and they will give you a board. Other ones need Gerbers and stuff. That's another video. I suppose I'm pretty cocky thinking I'm done. Let's go ahead and hit this design rule checker, because what happens is, if I forgot to hook up something, I wouldn't know. So I just click this, and it says all the pins that are supposed to be connected according to the netlist, which is the schematic, are connected. That's important. Now let's do the DRC. The DRC checks many things, all right? Track clearances, pad clearances, and stuff like that, and that's all okay. Let's make a mistake here, and you'll see what happens. If I took a via, and I connected it, if I put a via in a place that shorted two things together, which it won't let me do, by the way, unless I really try and screw it up. Well, let's screw it up and see what happens. How do I create well, here's the easiest thing to do. Let's not connect. Come on. Select this track and do that. All right, save. This is clearly not connected. If I do a design rule check and I forgot to do that, it shows up, oh, you forgot to do this. Oh, gosh darn it. What am I supposed to do? Track between, C4 and so on this layer and so on. So you can easily find them. If we do the DRC otherwise, it says your zone is out of date. Why? Because when I poured the copper, you'll notice this is not filled right there. If this is really supposed to be done, it should have been repoured after I did the last track edit. Now, the DRC is fine because it's not checking the routing, the routing connectivity. Let's close this. If I delete this one, now we do a DRC. It should say that this pad right there is not connected, which is different than saying that the thing is not routed. So now we actually have two things that are disconnected, and we start the DRC. It should say that I have a disconnected pad. Why does it not do that? I don't know. Unconnected pads. Well, that's interesting. That might be a bug in KiCad. I mean, you get what you pay for sometimes. But it certainly shows up when he says, show me the unconnected stuff. Now I have a disconnected pad, and then I have a disconnected track over here. So it's telling me about these two air wires. So I can just go ahead and connect them back up like this. Oh, heavens to Betsy. All right, now I'm the wrong size. Remember, I hit Q. And I wanted to make it 1, so now it's a big fat one. There you go. And the same up there. Hit escape. Save. Now look what's happening. I drew it over this filled region. If I do a design rule check now, it should say it's shorted. Well, actually, what it'll say is it'll say that your filled regions are out of date. Let's go ahead and do this. And when it warns us, let's say no this time. All right, now it should have said that I have a shorted network. Wow. It should have done that. KiCad, you're screwing me up here. Because it should have said, I'm shorting my power and my ground together right now. Okay, whatever. I did all that on purpose anyway, just to see what it would do. That's not very nice. But it did fail to report an error after I told it to ignore the other error, which was you need to redo your ground, your filled regions. Now, the reason I didn't do that, I want to show you how to do this yourself. If you're not selecting anything at all and you just hit B, what that'll do is it will repour all my regions on demand right now. I'm going to Control S to save it. Design rule check. Filled regions are fine. Everything's connected. Okay. This thing is ready to go. Alt 3. Let's have one last look at it. Woo, look. I got my name on the thingy, and it's open source, and I'm helping. Yay. Next time we'll cut this out and actually send it over to OshPark and see if we can get the thing made. If this was useful, let me know. Give me a comment or something, or a thumbs up. I'd appreciate it. See you next time.